so we are still in section, oh, I apologize, I should say section 8.1. So this is the B part. We've done integration by parts, and the last time we did integration by parts when we had exponentials. Now let's look at what happens when we have logarithms. Now as a reminder, the integral of the natural log of x, that's a pretty basic integral, but we don't actually know that yet. As a reminder, you can't take the log of 0 or negative. That's why we've got this little qualifier. We are mostly going to ignore that as we do this, though. So I'm going to set these up a little bit more formally than I did in the previous part with the exponentials. I am going to go ahead and just follow my formula. So I need a u and a dv. Now, I might be inclined to put the natural log under dv, like I did the exponentials in the last section, but I don't actually know how to integrate the natural log. That's the whole problem here. So I can't put it under dv. Well, that means I have to put the natural log of x as u, in which case dv is just 1 dx. So for these problems, for all of them, that natural log is going to be part of the u, not the dv. All right, the derivative of the natural log of x, as we hopefully remember, is 1 over x. And again, I'm going to put that dx in there for good notation. The integral of 1 dx is just x. So there's everything I need. I've got the left-hand side. So now let's follow along and get the right-hand side of the formula. So I've got u times v minus the integral of v du. Oops, I put the dx at the end. That's all right. Now, we have to be able to integrate this for it to work. For most of these problems, since you will have multiplication, you will need to simplify before you can integrate. But that simplifies pretty nicely. That is just 1 dx, and I know how to integrate that. So my answer is x times the natural log of x minus x plus my constant. And that is my answer. All right, let's try the natural log of 2x. Now, as a reminder, we do have understood parentheses around that 2x. So again, since I don't know how to integrate a natural log, every time I've got a natural log, that's part of my u, in which case the only thing left for dv is 1 dx. As a reminder, to take the derivative of a natural log, whatever we took a log of goes on the bottom, and then its derivative goes on the top. And this one does simplify as just 1 over x. Remember, if you need an extra step like that to simplify, that's perfectly okay. And then what is the integral of 1? Well, that is just x. So let's see what I get. So I get u times v minus the integral of v du. Well, other than that 2 in there, this looks pretty much identical to my previous problem. So again, I do need to multiply in here first. Again, you have to integrate before you can multiply, because I don't have an integration rule for multiplication. But that's a good thing, because that's a pretty easy integral. So I get x times the natural log of 2x minus x plus, of course, my constant. All right, so most of these log problems will look pretty similar to that. Let's do one additional problem. Now this one does also have bounds, so I will be able to check it with my calculator, but let's see if I can do it by hand. Now, I have division. My rule doesn't have division in it. So I might have to get a little bit creative with this. We know the natural log is going to be part of the u. Well, in that case, the dv is dx over x squared. And to help us integrate, let's rewrite that as with a negative exponent. So my du is 1 over x, and my v is going to be x to the negative 1 over negative 1. And if you want to just rewrite that as negative 1 over x, we certainly can. All right, so as I do this, I'm going to get u times v the integral of v du. Oh, let's put the dx in there as well. Now, technically, since we have bounds, we're going to go ahead and continue to put those bounds in there. And once again, let's simplify that a little bit. I'm also going to squish those first terms together and write it as one big fraction. I've also got minus a negative, so let's turn that into a plus. I get 1 over x squared, which is x to the negative 2. Well, I just integrated that. So here I'm going to get minus 1 over x. And again, instead of putting my plus c, let's put a line with my bounds. Now at this point, I do still then need to evaluate my bounds. Let's come over here to the left where I have more room. So remember, we put the top bound in brackets, and then we subtract the bottom bound. Now as a reminder, the natural log of e is just 1. However, we are still going to have those e's in the bottom, so I am just going to go ahead and use my calculator to help finish crunching those numbers. And when I type that in, I get approximately 0.2642. So again, I am not worried about getting the exact answer there. I am perfectly happy with an approximation. And again, we certainly could have done it with our calculator from the very beginning, but I did want to work one more example where we could see this. So this is our other integration by parts technique. So again, this version with logarithms, I went ahead and used that more formal version instead of the chart method. And this is now everything in section 8.1.